Damn. Yeah.
Assalamu alaikum and hi everyone, welcome back to our channel. So today I'm gonna teach you guys Math KSSM Form 5 Chapter 2 Matrix. Let's go. What is matrix? A matrix is a way to express two-dimensional set of number distributed in a simplified bracket. The elements are represented in rows and columns, which is useful in representing the equation and data as shown below. So as you guys can see, here we have a data that is in a table form, okay, that is arranged in a table form, but we can also convert it into a matrix form like this. So usually the bracket in matrix form is square bracket like this. So this is the row and here is the column going upward or downwards, rows from left to the right or right to the left. Okay, so that's it, and let's go. So representation of element in the matrix. Okay, so this one shows the position of the digit. Let's say here 1 1. Why? Because first row, first column. This one is first row, second column, first row, third column, like that. Okay, so this is how you identify the position of the digit in matrix. Okay, so let's take a quick example. So here we can see the question said that P is equal to Q, and it said that calculate the value of X, Y, and Z. Okay, so here we can see that some of the digit in P and Q are missing. Here we have X, in P we have Y, and we have Z. So in order to find X, Y, and Z, we know that P is equal to Q. So which means same position in P and in Q is the same value. So first thing, X is equal to 6, obviously, right? And then here Y, what is the value of Y? Y is equal to 2. This is Y and this is X, right? So Y is equal to 2. So how do we find Z? So as we can see that Z is in equation form, so might be a bit tricky, but it's not that tricky, guys. Let's do it together. 2Z minus 3 is equal to negative 2. We got this from P, this one is from Q. So simplify it. Negative 2 plus 3, then we got plus 1, and then we have 2Z 1 per 2. Z is equal to 0.5 or 1 per 2. So that is the answer for Z, Y, and X. Done. Move on to the next slide. Basic operation of matrix. So addition and subtraction. So as you guys can see, just now we know that we can identify the position of each digit in the matrix. So for this method, for this addition and subtraction, we can use that method to make it less complex. Okay, so might take a bit work, will take a bit of work. Okay, so it's okay. You see A, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column. Same goes to here, same goes to here, same goes to here, here. Wait, sorry. Same goes to here, and also here. So for addition and subtraction fundamental, you can see that in matrix, if we want to sum or subtract, we only the same position can we can interact with the same position only. So if A first column, if A first row and first column can be plus with A first row first column. So 16 plus 20, 18 plus 18 plus 15, 11 plus 9, 5 plus 7, 10 plus 12, 4 plus 5. Same goes to here. Subtraction 15 minus 20, 21 minus 15, 10 minus 9, and then we get the answer. Same goes to here. Alright, and let's do the example to make you guys understand. Alright, so it is given that the matrix C is 10, negative 8, 4, 6, negative 11, 7. Matrix D is 14, negative 2, 1, negative 3, 5, 9. So first thing first, the question asks C plus D, matrix C plus matrix D. So we know that matrix C is 10, negative 8, 4, 6, negative 11, 7, plus with 14, negative 2, 1, negative 3, 5, 9. Okay, so what would be the answer, guys? What would be the answer? Okay, so we use the method that we learned just now, how to determine the position of each digit. A11, A21, A22, A23, A2, sorry, A12, A13. Same goes to here. Blah 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 blah. So 10 plus 14, what do we get? 24. Negative 8 plus negative 2, negative 10. 4 plus 1 is equal to 5. Okay, so 6 negative plus negative 3 is equal to 3. Negative 11 plus 5, negative 6. 7 plus 9 is equal to 16. So this will be the answer for matrix C plus matrix D. Okay, that would be the answer. And move on to the next question. Matrix C minus matrix D. So do the same thing. Negative 8, 4, 11, 7, minus with 14, negative 3, 5, negative 2, 1, 9. So C minus D. So what will be the answer? So 10 minus 14 will be negative 4. Negative 8 plus negative minus negative 2 will be negative 6. 4 minus 1 will be 3. And then 6 minus 3 will be 9. Negative 11 minus 5 will be negative 16. 7 minus 9 will be negative 2. That will be the answer for this question. Move on to the next slide. Scalar multiplication. It is given that the matrix A is A, B, C, and D, and n is a number. Hence, NA is equal to n multiplied by A, B, C, and D, and is known as a scalar. So, for this one, let's solve this question. Given that matrix D is equal to negative 5, 4, 2, 1, calculate 3D and negative 1 per 2D. So, first thing first, to answer the question. To answer question A, first thing first, the scalar for question A is 3. 3 is the scalar, and then D is the matrix. So, which means all the digit inside must multiply by 3. Negative 5, 3, 4, 3, 2, 3, 1. Alright, so what will be the answer? The answer will be negative 15, 12, 6, 3. That will be the final answer. Okay. Move on. Question B. What is the scalar, guys? The scalar is negative 1 per 2. That is the scalar. What is the matrix? D. So negative 2 multiplied by negative 5. What is it? 4 to 1. Negative 1 per 2. 4. Oh, sorry. 1. Alright, so simplify it. So the answer that we get is 5 per 2, negative 2, negative 1, negative 1 per 2. That is the final answer for this question. Understand? I hope you guys understand. Move on. Multiplication with two matrices. So in order to do this, it's easy, simple. Okay, so between matrices, as you guys can see from this row, first row multiply with the first row in the column, in the first here and also here. Okay, so all you guys need to remember is that from the left you must multiply by using the rule and focus, and from the left from the right you need to focus on the column. Okay, row, column, row, column. And how would you do that? Okay, so first thing first, we're going to search for the first row, first column. First row, first column. How do we do that? 2 multiplied by 6, 3 multiplied by -2, then we sum it up and we get the first row, first column. And for the first row, second column, use the same row multiplied with the second column, so we get this. Okay, as we learned, guys, as we learned just now, that this one is, we want to search for first column, first row, first column. So what do we have to do? We take the first row multiplied with first column, and then we want to look for first row, second column. We take the first row and then we take the second column. Same goes to the other position. Okay, let's go and answer a question. Sorry. Okay, so what do we have here? So FG, we have matrix F, matrix G, matrix F. So the question asks us to F multiplied by G and G multiplied by F. Okay, so how do we do it? First thing first, we have -2, 7. Then multiply it with 4, 3. So what would be the answer? So here we want to look for the first column, first row, first column, first row, first column. So take the first row and first column. So -2 multiplied by 4 is -4 and -8. -8. And then we want to search for and then we want to search for a first column, first row, second column. -2 multiplied by 3 is -6. -6. And then we want to search for the second row, first column. 7 multiplied by 4 is 28. And then second column, second row, second column, we got 21. That would be the answer. Then for GF, 4, 3, 4, 3, -2, 7. We want to look for the first row, first column. 4 times 3. Wait. 4, 3. 4 times -2 is 4 times negative 2 is negative 8, and then there's no second column, so we look for the second row, first column, and then we also don't have second column, right? So wait. I think I make a mistake, guys. So for this one, there's only first column, but there is two row. There is only first row, so which is negative 8 plus 7 plus plus 3 times 21. Alright, that will be it. So inverse matrix. Given that A is equal to A, B, C, D, the inverse matrix A minus 1 can be obtained using the following formula. 1 per AD negative BC. So as we can see, B and C is doesn't have to change the position, but the value must be negative. Instead, while A and D must change the position. So for each of the following matrices, determine whether the inverse matrix exists. If yes, calculate the inverse matrix. So inverse matrix for question A. This one is A, B, C, and D. So the answer here will be 8, negative 2, negative 4, 1. Okay, so also we must put here AB, which is AB is AD is 8 times 1 minus 4 negative 2. The answer will be 0. So the inverse for question A does not exist. Question B is equal to 3, 2, 5, 4. After inverse, 4, 3, negative 5, negative 2. Okay, so AB 3 times 4 minus with negative 5, negative 2. So we'll get 12 here, and then we'll get negative 10. So it will be 1 per 2. And then 4, negative 5, negative 2, 3. Inverse exists. For matrix B exists. Okay, so move on to the next slide. So here is the answer. This one does not exist, this one does exist. Simultaneous equation with matrix. So this one, simultaneous linear equation. Ax plus by is equal to b. So matrix from Ax is equal to b, where A, B, C, D, P and Q are constant, contain while X and Y are unknown. Okay, so in order to find this, we need to move this matrix to the other side, which is we must go through inverse form. So let's try this question. 3, 4, 5, negative 6. 3, 4, 5, negative 6. Wait. X, Y equal to 12, 7. So move this matrix to the other side. So it will be, oops, sorry. It will be 1 per AD, which is AD is 3 times 6 minus 5, 4. Okay, in the bracket, in inverse term, negative 6, negative 4, negative 5, 3. Twelve, 7. So what we will get from here is negative 18, negative 20. So negative 18, negative 20 is negative 38. One per negative 38. So what we have to do first is multiply this matrix with this. Okay, so one by one. Negative 6 multiplied by 12 negative 6 multiplied by 12, negative 4, wait, give me a moment. Wait. So basically, ouch. Negative 60. So basically, 12 multiplied by 6 will be 12 multiplied by 6. Wait. So as you guys can see, final answer for this one is that 3 12 5 7. Yeah, thank you very much. That's it.